Hi everyone, this is Satish hooli, Department of Civil Engineering. Today we are going to see regarding WHD subject. In that we are going to see rapid sand filter. So rapid sand filter, first it was developed in 19th century in US. So when we compare to a slow sand filter and rapid sand filter, here the rapid sand filter, the filtration rate is much higher than that of an slow sand filter, approximately 30 times more. So we use in coarse sand and its effective sizing is of zero point 0.5 mm or so on. Okay, and the filtration range is also quite high. It is 100 to 150 liters per meter square per day itself. Okay, and this filter requires in small area itself. Okay, then we compare with respect to an slow sand filter. When you compare a slow sand filter, the slow sand filter requires a high space. It's a manually means for the cleaning purpose and all to control. It is more laborious. Okay, and these are sometimes costly because acquiring in land in a city area it is too costly. So by seeing that it is a costly. Okay, and even the rate of filtration is very slow than we compare to in rapid sand filter. So rapid sand filter requires a less space, first thing. Okay, and water is passed through a filter media with certain pressure. Okay, in a rapid sand filter. Now rapid sand filter consists of these various parts. Okay, so first one is an enclosed tank, filter media, base media, and under drainage system. So we are going to see this one by one, and this under drainage system, okay, has an two objective. So those objective we will see one by one. So enclosed tank. So enclosed tank as that of an slow sand filter and rapid sand filter, it's an watertight rectangular tank. Okay, it is built of machinery and concrete, same as slow sand filter also. The depth vary from 2.5 to 3.5 meters. Okay, the depth vary from 2.5 to 3.5 meters, and it is generally each unit. Okay, uh, the area is limited to 10 to 80 square meters, and it is generally kept a large. Okay, so here is an equation to find out the number of units. So n is nothing but a number of units, and we can find by using this equation, that is 1.22 under root q. Q is nothing but the plant capacity in millions liters per day. Okay, so each unit generally has a greater than of a capacity of one fourth, okay, of the capacity of the plant over here. So this equation we are going to use over here. Next one, the filter media. So we are talking about this filter media itself. Okay, so filter media generally has a depth of 60 to 90 centimeter in depth, and it is being supported by an gravel media over here. Okay, so effective size D10, it varies from 0.6 0.35 to 0.55 mm, and uniformity coefficient D60 by D10, it varies from 1.3 to 1.7 over here. Okay, and there is a fine sand at the top and coarse sand at the bottom itself, and it must be laid in layers. So generally around 3 to 6 layers it will be laid over here. The base media, okay, or the base material over here. So base material, what it does, it supports the fine sand, okay, media itself. So this base material which supports that fine sand, or you can say sand of, you can say filter sand media itself. Okay, so it is being laid around 5 to 6 in 5 to 6 layers, and it should be free from dirt, okay, clay, any organic matter, it should be hard and it should be durable. Okay, so the top layer is about 15 centimeter and the grade size is in between 2 mm to 6 mm. Intermediate layers are again 15 centimeters and 15 centimeters. The grade size here also varies from 6 mm to 12 mm, 12 mm to 120 mm. Okay, and the bottom, this has been typed or only itself. It is should be also 15 centimeters, and and the size here also it varies from 20 mm to 50 mm. The under drain system. So here the unique part of rapid sand filter is the under drain system. Okay, so what happens in slow sand filter, the under drain system are used to only receive the water, receive that treated water, and to deliver it to water supply lines. But here it serves two purposes. One is it collects the filter water which has been filtered. The another one is what it does a backwashing over here. Okay, so it help in cleaning that filter. Backwashing is nothing but it will help that filter to clean itself. Okay, it should be capable of passing back water or wash water at very high rate, because when you pass it with a high rate only, okay, the cleaning can be taken place. It should have non-settling velocity. It should, okay, it should have a non-settling velocity. Please remember this thing. Okay, and the velocity will range from 0.3 to 0.9 meter per minute over here. Next one, under drain system. Okay, here it has got two drainage system over here. Okay, one is in perforated pipe system. Okay, another one is in pipe and stain system. Pipe and strainer system. Okay, again they have gotten various forms over here. They like manifold and lateral system, wheeler system, and porous plate system. Again, these are the different systems over here. Okay, here it collect and the filter, this much rate is filtration is taking place and this water is being collected in that under drain system. So this system, two system which are there in and that under drain system, we will see these two systems one by one over here. The first one, the perforated pipe system. Okay, so these are nothing but these are the lateral drains which has gotten holes inside. Okay, the holes diameters are 6 mm to 13 mm diameter and it has an angle with vertical of 30°. So this is being shown over here. Okay, usually it is made of a cast iron and the center to center spacing is between 15 centimeter to 30 centimeter in center to center. The hole spacing here is between 75 mm to 30 centimeter. The holes which are being bored here, those spacing we are speaking. And to prevent the rusting, what they do is they use in brass material over here in this part, and these laterals are being supported by concrete blocks, okay, of thickness 40 to 50 mm thick, and which is being placed at the bottom on the filter floor itself. Okay, so all this is all about perforated pipe system. Next one, the pipe and sending system. So this one, what it does over here is, okay, this will be like an umbrella shape over here, or this will be of a cylindrical shape. Okay, so here what happens there is to the lateral, the strains are inserted by drilling a holes here, and they are usually of an brass or an bronze material. Okay, and they are made up of an umbrella shape. You can see this one is of an umbrella shape over here, this one. Okay, or sometimes a cylinder. Here what happens here is the wash water which comes out, okay, from this drain and without having a jetting action. So if it has a jetting action, what happens there is it disturbs the filter media. Okay, so jetting action should not be there. So it does have non-jetting action. And sometimes what happens to here is a special air orifice is being employed. Why it is being employed? Because air wash is being used. So what we do is we tend to pass out a compressed air in this system. By doing so, what we do is we'll clean up that filter media itself. Okay. So this is about what pipe and stainless system. Okay. So now we will see working and cleaning operation. So this is an rapid sand filter. You see here the volts 1, 2, 3, 4, 5 and 6 over here. The first one, it is nothing but inlet raw water pipe. So where the raw water enters in this chamber itself, it is called as an inlet chamber. Okay. The second wall, which is nothing but it's an wastewater wall to drain out the inlet chamber. So from this, uh, uh, there is an water over here. Okay, so that if you want to drain out, this wall is being used, and this is connected to a gutter itself. Okay, or we can say a drain. Next one, the third one. The third one, it is nothing but it's a wastewater wall connected again to the main gutter itself. This one only. Okay. The fifth one. Okay, sorry, the fourth one. Fourth one is nothing but it's a filter water supply pipe which is being connected to an distribution unit. So this is connected to an distribution unit. The fifth one wall is nothing but it is of wash water supply wall. This one. Okay. And sixth one, it is nothing but it's a compressed. Okay, it's a compressed air wall itself. So remember this walls itself. These are very much important to understand the cleaning process or how it is works. So when a treating process is going on, when the filtration process is going on, so what they will do, they will open wall number 1. This wall is being opened, and they tend to open wall number 4. Rest of all the walls are kept closed. The second, the third, the fifth, the sixth, all the walls are kept closed. Only 2 walls are being opened, the 1 and the 4th. So raw water is getting into the inlet chamber. It is passing to the chambers. Okay, it is passing through the filter media itself, through the base material itself. Okay, it is percolating, it is getting filtered, and it is coming out from the drains itself. So now, as per this statement, you can see over here is, okay, wall number 1 is opened, and which lets the effluent from the coagulation sedimentation tank basin, and which enters the filter itself. Okay, and the filter water from the filter bed, filter water is taken out, okay, from the main drain operating from the wall number 4. So it is been taken down, and it is been connected to distribution network itself, okay, or where you want to supply that water, or you can say it is connected to an disinfectant unit also. So after this one, we generally we have a disinfectant unit. Okay, so during a filtration process, what happens here is only wall 1 and 4 are kept open. Rest of all walls are kept closed. So water enters to this inlet chamber, passes through the filter media, laterals, then to the main drain, and from there it passes through the wall number 4, which is been connected to the distribution network or to an disinfection unit itself, and okay, and water is being collected. Okay, so this is all about operation or working itself. Now backwashing. Okay, so when the backwashing is being done, when here you can see there is an indicator. What it shows here is head loss indicator. When you have got in succession head losses or the sand becomes dirty, at that time what happens, there is much of head loss. The filter is been getting clogged. Due to that, filtration is not taking place. So that time what we do, we use cleaning operation. Okay, now what we do for the cleaning, what the raw water supply as well as the filter supply is been cut off. So this wall number 4, 1 and 4 are been cut off. Okay, and what we do, we open up as per this statement only we will go, then we will see. What we will do is we will pass, okay, or we will, what we do, we will put an upward movement of wash water and compressed air through the sand particles, and which removes the suspended impurities from the filter itself. So what we do, we pass the air, compressed air, and as well as the water. Okay, and by doing so, what we do, we remove that impurities, okay, which has been clogging that filter media itself. So for this operation, what we do, we close wall number 1 and wall number 4. Now wall number 5 and wall number 6 are being kept opened. Okay, and what we do, the wash water and the compressed air are thus forced upwards through the drain, through the gravel and sand bed. So these are forced upward. So there is movement upward in opposite direction. Okay, then what we do, we close that wall number 5, that compressed air wall, we are going to close it when we got a sufficient amount of air. Okay, now the dirt resulting, this dirt or that coagulated dirt which is coming out, that has to be removed out. So that will be removed out through this wall number 2. You are opening out this wall number 2. Okay, from here what is happening here is you are removing out the dirt. Okay, and that wash water, it is bent sand to that gutter itself, and this process, okay, will is continue for 3 to 5 minutes unless all that dirt is been removed out. Next, what happens here? Okay, so after this process is been completed, what we do is you close wall number 2 and wall number 6. Then you open wall number 1 and wall number 3, not the wall number 4. Okay, and that water is not to be collected for filtration again. Okay, that has to be thrown through the gutter only, because there will be some impurities will be there left out. Okay, certain particles will be there that should not be sent through to that distribution network itself or disinfectant unit itself. And unless what happens there is, okay, the remaining water, okay, must be removed out, that is there, unless a surface mat is being allowed to be formed. Here the surface mat should be allowed to be formed. So when it is formed, okay, then only the filtration take place very much properly. And ultimately what we are doing is we are closing wall number 3 and we are opening up wall number 4 over here. Okay, and this is all about back washing itself. So thank you. You can see in rapid sand filter over here, this is wall number 1, wall number 2, wall number 3, wall number 4, wall number 5, wall number 6. I will explain this again. When the filtration process is taking place, you need to keep off wall number 2, wall number 3, wall number 5, wall number 6. Only wall number 1, wall number 4 is being opened, and water gets into that inlet chamber through that filter media. It turns to percolate through the gravel bed or the base material. It is being collected into lateral, then to the mean, then it is being supplied through the wall number 4 to the disinfection unit or the distribution network. When backwashing is taking place, what we need to do is you need to cut off the raw water supply and what the treated water supply part. Okay, so wall number 1 and wall number 4 is being closed. You are opening at wall number 5 and wall number 6. The wash water as well as that compressed air which has been passed through that gravel layer, gravel bed and through the drains itself. Okay, and when you got insufficient amount of air, okay, so that time what you need to do is you need to close wall number 5. Okay, then that water enters to that inlet cabin, then that wastewater you need to remove it out. Okay, and that is being removed out from wall number 2 and which enters to the gutters, and this process is continued for 2 to 3 minutes. When sufficient washing is being done, what you are doing is you are closing wall number 6 and wall number 2. You are opening wall number 1 and wall number 3, and you are supplying raw water. You are not opening wall number 4 because there will be some impurities which will be present. Those things has to be removed out, and it will be removed out from wall number 3 which is connected to the gutter. Okay, and few minutes it will be continuing out. Then what we need to do is you need to close this wall number 3 and you need to open up wall number 4. Then the water is passed from one wall, it is been through those filter media to the lateral through the main drain and passes to the wall number 4. Okay, it is connected to a disinfectant tank or distribution network. So this is all about working and backwashing process of rapid sand filter. You can refer SK Garg book page number 509. Okay, 509 you can refer it. And with respect to rapid sand filter, you have got in page number 517. So thank you very much. Stay home, be safe. Okay, thank you very much.